Hello everyone, welcome to this course on fixed income for the Master in Finance at Nova School of Business and Economics. Well, this course was not designed to be an online course, but we are in the middle of the COVID pandemic, so this is my attempt to help you understand the material. As you will quickly see, these are not professionally made videos. I'm making these videos at home in my computer, so they will have some flaws for sure. Okay. So what I will do is I will follow the handouts that are posted on the website, and I will try to highlight the most important parts of the handout. So I will not cover the full handouts. I will just try to focus on parts that people typically find more difficult. Okay. The handouts are based on two very good books, Veronese and Hull. Those are the main references for this course, which I encourage you to read. Okay. All right. So let's start. I'm going to switch to the handouts again. These are posted on the web page. In this first video, we are going to cover the first chapter on fundamental concepts. So most of the material here, I think, is things that you have seen before in other courses, like investments. So I'll go very quickly over this first chapter. This basically, the purpose of this chapter is just to review fundamental concepts like bond prices and interest rates and so on. We will also define the notation that we will be using throughout the course. And these last two subsections, 1.5 and 1.6, are actually very important in the sense that these are building blocks to everything that we will be doing afterwards. So we're going to be looking at the prices of bonds, derivatives, and so on. And the basic tools to price all those things are the price of a fixed rate bond on one hand and the price of a floating rate bond on the other hand. So I imagine that most people that are doing this course now know how to price a fixed coupon bond, but I also think that most people do not know yet how to price a floating rate bond. So I'll go slowly on this last section 1.6. Okay. All right, so let's start. A brief look at the market. This table that you have here, increase the size of the, probably better like this. Yeah, so this table that you have here, it comes from one of the two main books that we're following, Veronese. It's for the U.S. market. The course is focused on the U.S. market for two reasons. One is that the books are also focusing on the U.S. market, so we're going to follow those books. And also because the U.S. market is obviously one of the most important markets in the world. And actually a third reason. The third reason is that most of these things that you see in the U.S. market, then you also see them in other national markets, like in the Portuguese market or in the German market or the Italian market and so on. So most of these concepts are replicated in other markets, just with different names. Okay. So again, this is the US market, and what we have here is the relative size of different markets. So the US Treasury debt, so bonds issued by the US government, had a market value, this is in 2008, of $5.9 trillion. A big number, okay? And it's a big number by any measure, and it's an absolute large amount of money. And if you compare to the gross domestic product of the US, which in that year was $14.7 trillion, it's large, right? So the debt market here, it's about a third or so of the GDP of the country. In other countries, this fraction is even larger. So it's very common for the government debt to be 100% of GDP or even more than 100% of GDP. So if a country wanted to pay the whole debt, people would have to work for a full year and do not eat and use all that money that was generated in 1 year to pay for the debt. So by any measure, this is always a huge market in any country. So we will spend a fair amount of time in this course talking about this market. Okay? These other two markets here, municipal debt and federal agency securities, are a bit specific to the US market, so we will not focus so much on that. But then we will also talk about the money market in general, okay, which is also a big market. So half of our course, more or less, will be about this. Okay? Then the second part of the table here, it's about derivatives. And here, if you look at the first one, interest rate swaps, you see a huge amount of money, right? This is $328 trillion of notional. So this is not exactly the same thing as the market value. These are not, we're not comparing apples to apples, but still, I mean, this is a huge amount, right? It's 2 orders of magnitude larger than the government debt market. So we will spend the second part of the course talking about derivatives, and most of that second half will be about this market, interest rate swaps. Because again, as you can see here, it's clearly a huge market. There's a lot of trading in this market, so it's important, and we'll spend a lot of time on interest rate swaps. Okay? We'll also then talk a little bit about other derivatives like interest rate forwards and futures, and a little bit about interest rate options, which are also big markets, as you can see here. Okay. In this course, we will not talk about US corporate debt. So this is bonds that have credit risk, and there will be a separate course on credit risk that will deal with that type of bonds. Right? Pretty good. So brief remarks about some of these markets. So let's start with the government debt market. In the US, you have different names for these securities issued by the government depending on the maturity. So if it is a short maturity, up to 1 year, we call them Treasury Bills. And if it is larger than that, but until what happened here? Oh, this table is a bit weird. I should format this better. But so I was saying, if it is after 1 year, then you have notes and bonds. We usually don't distinguish too much between notes and bonds. We just call everything bonds. But there's this more formal definition that a note has a maturity between 2 and 10 years. And if it is over 10 years, we call them bonds. But again, in the course, we'll not make the distinction between these two. We'll call everything treasury bonds. Okay. This is a bond, or it used to be a bond or a note. In the old days, this was really a piece of paper, like you see here. Nowadays, you don't use paper anymore. A bond is just a record in a database, so it's not any material. It's not a material thing. It's not anymore a piece of paper, but we still use the words that came from this time. Okay, so for example, you have here this piece of paper, and here you have this value written here, $1,000. So we call this the face value of the bond, because it's the value that is written right here on the face of the bond. Okay, so you would, in these old days, you would buy one of these papers, and that paper represented $1,000. Okay, then it also says here this interest rate, 9%. Which is the interest rate that the bond is going to pay every year. So 9% over these $1,000, right? There are more details here, like the date when it was issued, and the due date, which would be the maturity date. So in this case, the bond would end on February 15th, 1987, right? And then, so this was this initial piece of paper, and then down here, you would have all these coupons, all these small pieces of paper, and you would actually, every 6 months, you would actually detach one of these small coupons, and you go to the bank and you get your interest. And it says here when do you need to go to the bank, what is the date, so when it's the date of the coupon payment, and how much money you get on that date. So $45 in each coupon, right? So which means that the coupon rate, this 9%, is actually paid twice per year. In each payment you get 9% divided by 2, which so 4.5% times $1,000 gives you this $45. Okay. So again, we're going to still use these words of coupons and so on. Okay. So as I said in the beginning, there are more details here in the handouts that I encourage you to read. I'm just going to go over this quickly here in the video. Okay. One important type of bonds are what we call zero coupon bonds. And as the name suggests, these are bonds that do not pay coupons. There's a zero interest rate. And therefore, they only pay the principal at maturity. Okay? So one example are the Treasury Bills. So those bills, those government-issued securities that mature in less than 1 year. Okay? So typically, they don't have an interest rate. So they are zero coupon bonds. And then you also have for longer maturities, you have these strips, which are coupon bonds that are separated. So you strip the coupon of a coupon bond and you sell it separately in the market, and that separate coupon becomes by itself a zero coupon bond. Okay. All right. Let's just briefly talk about a different market, the money market, which is this short-term market for large firms where they borrow and lend for short maturities. This market is important because we are going to use the interest rates that are determined in this market for several applications. Okay, one important rate is the LIBOR, the London Interbank Offered Rate. I mean, it's by far the most important rate in this market, because we use this rate as a reference for a bunch of other products, like the derivatives we're going to talk about later on. Okay? So the LIBOR is actually being terminated at the end of this year. It is not very clear yet what rate will be used after LIBOR, but there's a lot of discussion going on. I posted here some links, so I encourage you to look at these and to follow on what's going on in the market. Okay. One important type of trade that we can do with government bonds are repurchase agreements. So let's define what they mean, what they are. Okay. So basically, a repurchase agreement, as the name suggests, is a contract where you first sell something, and at the same time, you agree to repurchase it back later on. Okay. So basically, what you're doing is you're borrowing money using collateral. Okay. So let me try to show this with a figure. And again, if I was in class, I would be drawing this on the board. Since I cannot do that here, I have done the drawing beforehand, and this is it. So let me try to walk you through what's going on here. So you can see my mouse. All right. So this is a repurchase agreement. So focus here on the first part of the figure. And we are taking the view of a trader. Okay. So this guy here in the middle. So the trader goes up to a repo dealer, and what he does in the beginning today, small t, is the following: he delivers a bond, a government bond, to this repo dealer. The repo dealer will be a big investment bank. Okay? So the trader might be, for example, a hedge fund. So the hedge fund delivers the bond to the investment bank, and in return, it gets the market price of the bond. And this is called a repo, again, because at the initial point, we agree to later on, at the later date, capital T, to reverse the trade, meaning we get the bond back and we pay to the repo dealer the price, the initial price, plus some interest. Okay, and this is the repo interest rate, right? So why would I want to do this? What's the point of a trader doing this? Well, the point is that the trader can do this repo transaction to basically finance the purchase of the bond in the bond market. Meaning, at the same time that we are doing these transactions, we're doing these other transactions here in the bond market. So the trader, at the initial time, gets the bond from someone else, from some other fund that has the bond. Okay, so he buys the bond on the market and obviously has to pay the initial price, right? So these flows here cancel. The trader gets the bond from the market and delivers the bond to the repo dealer. It gets the money from the repo dealer, and that's the money he uses to fund this purchase. Okay, so everything cancels here. At the later date, the trader has to close the repo deal, so he gets the bond from the repo dealer. He delivers the bond to some other fund, or he sells the bond in the market, basically, and he gets the market price of the bond at that moment, right? So basically here what we have is what is a long position in the bond. The trader has a long position in the bond because he first bought the bond and later on he sells the bond. So basically this is a long position because he benefits from an increase in the bond price from this P small t to P capital T, right? So if the, sorry, turn this off. So if the bond price goes up, the trader makes money, or more specifically, the trader will make money if this price here, this final price, is large enough to compensate for the initial price and for the repo interest rate, right? So that's a repo trade, okay? We can do exactly the opposite, a reverse repo, okay? A reverse repo is what you see here. And this is the usual thing, that the repo dealer is like a trader that always quotes two sides of the trade, a bid and an ask. So we can do one side of the trade, the repo trade, or we can do the other side of the trade, the reverse repo. So how does that look? So again, let's take the point of view of the trader. Everything is the same, but now the arrows go in the reverse direction. So we first get the bond, and we pay the market price to the repo dealer. And when we close the trade, we do the opposite. So we give the bond back to the dealer and receive the price plus interest. Again, exactly the same, but going in the opposite direction. Now, why is this interesting? Well, for the trader, what can he do? He got the bond from the repo dealer, so he can sell the bond now in the market. And he gets the market price. Again, these initial flows cancel, so the trader has a zero cash flow at this moment. Later on, he needs to close the repo dealer, so he needs to buy the bond from someone else on the market and pay the market price at that point, and uses the bond to give it to the repo dealer, and he has to pay the market price. So now the position of the trader is a short bond, right? Because he first sold the bond and then he buys back the bond. So he's betting on the price to decrease, right? So he will make money if this price PT is lower than that, or more specifically, if this price P capital T is smaller than this amount that is coming in here, right? So this is important because this is how we short a bond. Okay, so in the future, whenever we say that we have a negative position in a bond, we mean that we are selling a bond or shorting a bond like this, right? Okay, let's go back to the PDF. Here, PDF. All right, one more detail about price quotes. So bond prices are used to be quoted in dollars. So for that example we saw before that had a face value of 1,000, you would find the price, market price of the bond around that number. So it might be 950, 980, or 1,020, something like that. So a price in dollars around 1,000. Nowadays prices are not quoted in money anymore. They are quoted in percentage. Well, percentage of what? Percentage of face value. So that is sometimes a little bit hard to understand. So I think the best way to think about the meaning of that price as a percentage of face value is to think about it as in this equation. So this is the market price that you see posted in Bloomberg, for example. Okay, and what it means is that if you multiply that number by some face value, think of this as the quantity of the bond. That's the product of those two things. It's the total amount of money you need to spend if you're buying, or that you receive if you're selling. Okay. So quick example. So suppose that the bond with 5% annual coupons is priced at 102.1234. Okay, so this is the market price, this number here. Okay, so what does that mean? So if we have $1 million to invest, okay, the quantity of the bond, meaning the face value of the bond that we are going to be able to buy, is given by this equation. So 1 million on the left, here the price is 102.1234, and then I can solve for the face value. So the face value will be the $1 million divided by 1.021234, right? And that will give me a face value of this amount here, right? So again, think of this as the quantity of the bond that you're able to buy. Why do I care about this? Well, because it is this face value that determines exactly how much money am I going to get in the next coupon payment date. So the next coupon will be what? Will be the face value, this amount here, times 5%. Okay, and that will give me this amount of money, that is $48,960 that I will receive on the next coupon payment date. Right? In the end, at maturity, what I will receive is this 5% coupon plus this face value. Okay, and that will give me this total here. All right. Okay, last topic here in this video, some quoting conventions. This is a type of material that is not very interesting because this is very specific to the way the market works, and these are details that we're going to cover this here because we need to do this in some examples, and we need to know how to do this when we get to do some trading. But there is not much science here. This is just definitions of how things are used in the market. Okay, so the first quoting convention is Treasury bills. This is very specific to the US market. This does not make any sense to me. I don't know why they do this. I'm just writing this here because in the book there are some examples and some exercises, and this is how they quote Treasury bills. Okay, so please read through this, do the exercises, and if you have any questions, let me know, but I don't want to spend time doing this. Okay. Second quoting convention for Treasury notes and bonds. So this one here, it's more important because this is common to other markets. So we need to understand how this works. The bond price that we're going to talk about in this course, which is the total amount of money that I have to pay for a given bond, is what we call the invoice price, or some other words like dirty price or full price or cash price. So this is the actual amount of money that I need to spend to buy a bond, or it's the total amount of money that I get if I sell the bond. However, for some reason, some people, or in some markets, instead of quoting that number, what traders do is they quote a different number called the quoted price, or the clean price, or the flat price. So basically what they do is that they take the full price that they think the bond is worth, and then they separate that into two components. One component is the quoted price that they show, and the other part is this thing called the accrued interest. Actually, what we do is in the reverse order of what I just said. So we have the total price that the bond is worth. We compute how much is this accrued interest. We subtract this accrued interest from the total value of the bond, and we quote what is left. That's what we show in the Bloomberg terminal in the market, right? So we're going to spend a lot of time in this course talking about how to determine the initial thing, the full price. And here we're just going to determine how, we're just going to look at how the accrued interest is determined, okay? To make things even more complicated, the way this accrued interest is computed depends on the actual market. So the Treasury market for notes and bonds may use some day count convention, like actual over actual, which means that you actually count days based on the calendar. In other markets for corporate bonds, we simplify things and assume that every month has 30 days and the whole year has 360 days. And then in other markets, we mix these two things and we do this mixed definition here, which is in the numerator, we look at the actual calendar to count days, but then in the denominator, we assume that the year has 360 days, okay? Again, this does not have any relevant implication. This is just a definition of how the markets work. Once we know how they work, we can compute the interest and we can compute the price that we should quote, and everything is fine, okay? So we just need to do this once to understand how it works, and then let the computers do this until we actually need to fix some code or to do some complicated thing with these definitions, okay? So let's see this with a quick example. So we have here a bond. So this is the 15th of July 2020 4% bond. So what this means is that this is the maturity date of the bond. This is the coupon rate. It's always an annual figure, okay? And then it also says that it pays semi-annual coupons. So it's more or less like that bond we saw in the beginning. It's that type of security. We are trading the bond, so the settlement date is on the 10th of April 2012. Okay, and for these day count conventions where we really count days by the calendar with actual, we have to take into consideration whether 2012 is a leap year or not. Okay, and it is a leap year. Okay, 2012 is a leap year, meaning February has 29 days. All right. So let's see how we compute the accrued interest. Let me open the drawing here. Not this one. It's not picking up the right one. Sorry. Let me close this window. Okay. So this is the example, right? So again, this is a bond that pays coupons every 6 months. So if it matured on the 15th of July 2020, so when I was in 2012, these were the two dates where there was interest payments, on the 15th of July and 6 months before that on the 15th of January. When we are trading here on the 10th of April, right? So the next coupon that is going to be paid is this one here, 4% divided by 2. And we can think of the accrued interest as the fraction of this coupon that corresponds to this amount of time here, okay? So we can think of this as the part of the interest that belongs to the investor that has the bond here, okay? That has held the bond until here, okay? So I'm going to separate this amount of interest from the total bond price, okay? So again, the point is, how do I compute this fraction of time here relative to this whole coupon period, all right? Again, there are different alternatives. Let's look at two alternatives. So one is actual over actual, okay? Meaning I actually look at I look at the actual calendar for this period, right? So let's count how many days are between this 15th of January and 10th of April, okay? 15th of January and 10th of April on the calendar, all right? So January has 31 days. So from 15th to 31, you have 16 days. Then February in a leap year has 29 days. March 31, and from here to here 10 more days. So the numerator in the accrued interest is 86. Okay, and then I keep counting the remaining days until the 15th of July. So 20 more days in April, 31 days in May, and so on. So I get this whole amount of days for the full periods, and that's the denominator of the accrued interest formula, right? So the fraction of this 2% that I get is given by this ratio. Alternatively, if the market specifies that we use a 30 over 360 days basis, what I do is assume every month has 30 days. So I count the days here again, assuming January has 30 days, so just 15 days. Then February has also 30 days, and so on. And that gives me 85 days in the numerator, 180 days in the denominator, and I compute the accrued interest like that. Okay. All right. So I'll stop here and then continue on a second video.